So in this webinar, I'm going to talk about a little bit how we can deploy Nextflow pipelines into the cloud. The aim of this webinar is to give a sneak peek of like the practical, sort of like a practical introduction how to do that. So I'm going to be presenting, as Flamina said, my name is Martin Berger. Alejandra is going to be in the background and to help me out if I have any questions. We just going to start. The plan for this webinar is to cover a little bit of what's the purpose of the workflow management systems. What do we need those, especially in bioinformatics. Then I'm going to move over to Nextflow, which is one of those systems. I'm going to talk about a little bit of what some of the features that Nextflow have and the architecture, how actually that fits within the executing pipelines into the cloud. Then I'm going to talk about a bit how Nextflow communicates with Google Cloud, which is the cloud provider that we're going to use for this webinar. And finally, I'm going to do a very quick demo of how we can actually deploy a real pipeline into Google Cloud. A bit of a disclaimer, we are not affiliated with Google, just to make it clear. And myself, I am part of the Nextflow Ambassadors program. You can search for that if you're interested in that. So just to sort of like set the scene and a bit of the context for this webinar, what are workflow management systems and why do we need them? I think most people working in bioinformatics is going to be hopefully reflected in this next few slides. So let's go over what I consider bioinformaticians do. So they are given a task, you need to run interproscan on this assembly proteins, and then you basically take the tool, install it locally, and then just look out the parameters and just like run it. And this is how you run interproscan, like minimally how you run it. It has a bunch of like flags, like the number of CPUs that you need. You have a bunch of parameters, like it has some kind of like database dependency there you need to specify, and then you basically give it the input file, which is going to be your proteins, and then it gives you back an output file, which in this case is a TSV file. So all good. You run that either on your local machine, or if you have access to it, you run that on an HPC cluster, and everything's fine. So then you in your research project, you want to use a different. In this case, there's a tool called Santis for the detection of biosynthetic gene clusters. So this tool has a dependency. Okay, you need to feed it back. You need to feed it as an input the annotations that you got from interproscan for your assembly. So again, you look for the tool, you install it, and then you run it. And you basically specify a few parameters for it. Basically, input file that comes from interproscan, and where do you want to keep your output file. All good. So this is sort of like, you notice that you need to start running this for many different assemblies. So you sort of like stitch them together in some kind of bash file probably, or something like that. So basically you run interproscan first, and then basically, and then Santis afterwards. And then it's sort of like, there's sort of like a dependency between these two projects. So the output of the first one of interproscan is a dependency for the first one. And that's fine. This probably works most of the time. It may fail every now and then. It's just like you manually go and retry things, and everything looks good. But if you think about running this for hundreds of thousands of assemblies, then it becomes a bit of an issue. So you don't want to be running this like manually all the time, because you start to notice that things. For example, what happens when, for example, interproscan fails, and then do you run Santis? How you recover from that? What happens if, for example, you have two tools in the same environment that have like colliding dependencies? That's sort of like how you manage the software in that setup. Again, as I was saying, if you have many samples, it becomes a bit of an issue. So you may have like use some facilities of HPC clusters, but then you need to know the specifics of your HPC cluster, how you do isometer jobs, how do I manage all of that. And I'm not even considering how do I even run this on the cloud. So there's our ways of doing this. You can do it manually. You can probably build your own workflow management system using Bash and whatnot. You probably can get away with that. But there's a better way. And so Nextflow is basically the tool that allows you to do that. There are other tools, workload management systems out there. We are going to focus on Nextflow in this session. So Nextflow is basically is two things. It's a language to write pipelines, data-intensive computational workflows, but it's also an orchestration engine. So it takes care of like defining and taking care of how the data flows through your pipeline and handling software, handling all of that, but also allows you to execute your pipeline. So it's sort of like I like to think about like you write it once, you can run it locally, you can run it on an HPC cluster, but you can also run it in the cloud. So let's take our example and try to build a mini workflow from that. This webinar is not an introductory webinar around Nextflow itself. So I'm going to go over some of the concepts on Nextflow quite quickly, but I do have links at the end about how, if you want to learn more about Nextflow itself. Well, in this case, we took the interproscan command line bash thingy that we had, and we'll export that into Nextflow. Nextflow has two main components on defining workflows, which are like the processes and the workflows. Basically, a workflow is composed of many different processes and sub-workflows. So those are the two building blocks. We will touch base on that on the next slide. But you can see here, this is sort of the definition of the interproscan result. Hopefully you can see my mouse pointer, otherwise gloss over to the end of it in the script tag. You can see there we have something that really looks like the instruction that we have in the past few slides. So like this is how you run interproscan. You are sort of somehow specifying how many CPUs. Again, the DB, which was a requirement of the tool, the input and the output. So you can sort of like start mapping that out if you are not familiar with Nextflow. But there are a few things that link back to some of the challenges that I was saying. For example, Nextflow supports containers like Docker containers or Singularity containers. For those that are not familiar with that, basically a container is like a way of isolating software in a self-contained unit. So basically, you isolate the software environment from the rest of the pipeline. In this case, we are specifying, okay, this process, interproscan needs to run using this container. So that's one of the first challenge that we solved. How do we run this on how do you isolate software environments? The second thing you can probably look at there is like, I am specifying the number of CPUs and memory this process requires. When you think about running your processes outside of your laptop, for example, in HPC cluster, for example, in the cloud, it's quite important to know how many resources any given process is going to need. So this is how you specify this in Nextflow. More on the process itself. So you can see here, okay, these are the inputs that this process is run. This is my FASTA file with the proteins and the interproscan reference EBI. And these are the outputs of it. So it's basically generating a TCV at the end. And again, as I was saying, this is a script. This is how you execute it. And so, as I was saying, this is a way of, this is one of the components of Nextflow. This is how we basically define, so a pipeline in Nextflow is basically two main components. Processes, which are the tools that you run, and a workflow, which is basically all the different processes that you need to build a pipeline. On this slide here, what you can see is how you basically define a process for interproscan, which was one of the tools that we talked about in the previous slides. So it has some components there. I'm going to go over them one by one again. So first, it has a way of defining which software environment I'm going to use for this process. In this case, I'm going to use interproscan, and this is using a container. A container is a way of isolating like a software environment in a nice to use, like you can think of like a lightweight virtual machine. Then you can specify how many resources your process needs. For example, when you're running your pipelines in cloud providers on high performance compute cluster, that's quite important. You need to know how many CPUs your process is going to need, how many memory, how much disk. You can specify all of that within the process itself. So this is how you do it. For example, CPUs, I'm saying, okay, this process needs to run with using 8 CPUs. The second, like the basic building block of that then from the process itself is like, okay, I need to specify inputs. These are basically the FASA file, which I need to process. And then the second parameter of the tool itself, you can see path, which gives you a hint, okay, this must be a file. And then basically keep track of what is the output file of this process. You can see here is anything that is like a TSV file, which I'm generating out of this process. Again, this is a script. And if you look back to the previous slide, you can see, okay, this is how you run the process. This is like a self-contained bash script within the process itself. So how do we keep building on this? So I was saying you have processes and you have workloads. So you can see here I have two processes, Interproscan and Santis, which was the other tool I was talking about. And you can see this is the second building block, workload, which I name annotate. It doesn't really mean anything, it's just a name I gave it to the workflow. And you have like two main components of the workflow. The main one, which is actually what the workload is going to run, and then the emit, which gives you an idea, okay, this workload is going to produce this output. And the workflow itself has three main lines. The proteins, which I'm only saying in case this is going to be a protein file, and challenge is quite a central component of Nextflow. Please do, if you're not familiar with them, please do go to the training side, which I link at the end. So I'm saying, okay, this proteins variable here is going to store a link to a file, which I then feed into Interproscan. So Nextflow itself is going to take care of like staging the file. It's going to feed directly into the process, and it's going to run the process for me. What it's going to do afterwards is going to basically the output of Interproscan, because you can see here Interproscan, if you look at the Santis line, it says that process needs an input, which is basically the Interproscan result. So you can see the implicit dependency that we had in the bash version of this is taken care by Nextflow here. So Nextflow is going to take care of staging the files, the inputs and the output from different processes. So and it's going to figure out how to run that on its own. So we don't have to specify that. We just by having inputs and outputs on different processes, Nextflow is going to build a tag, which is like a graph on that, and it's going to execute that for us. Which links me to this is a nice diagram of how Nextflow works. And as I was saying before, Nextflow has two main components. So Nextflow, let's call it pipeline, which is this diagram on the top, which is basically the domain-specific language, which I use to write my workflows, which allows me to write my workflow using any language. So within the script tag of a process, I can have any language that I want, provided that my software environment supports that. It's gonna, using this data flow programming paradigm, basically the inputs and outputs from different processes basically tell Nextflow how to execute things, and we figure out the order of that based on that. And then it allows me to specify the software dependencies using containers. It also supports contact for those that are more familiar with that. And a really nice thing, which I'm going to quickly demonstrate on the demo, is that it has a built-in integration with Git. So it allows us to very quickly share our pipeline. That's one component of Nextflow. The other one is the runtime or the execution layer, basically. So Nextflow did a very good job in separating how you actually define your workflow and how you run it. So those things are pretty much independent of each other. So the Nextflow runtime actually supports a wide range of platforms. You can run things on many different APC clusters, things like probably Slurm. Many of you are maybe familiar with that, or the Grid engine on LSF, IPM LSF, that sort of thing. But it also supports some cloud providers like AWS, Google Cloud, and Azure. Just a little bit on this, because I'm gonna go over this bit on the demo. So I just want to make sure everyone understands. So I was saying you have Nextflow, you define your workflow in this specific, like domain-specific language that basically using those constructs like process and workflow and whatnot. And then you basically define a config, and the config file is going to tell you, okay, where do I need to run this? Do I need to run your workflow in locally? Do I need to run this on an HPC cluster? Where do I need to run it? And you basically in that config file specify all the different bits that you need to actually make it run there. For example, I have very minimal example of one of those configuration files. So basically the same workflow, different platforms. And you can see here on these profiles here and there, basically have 3 profiles, one called local, which is gonna specify, okay, I need to run this workflow using my laptop. That's what local means. I have another one called cluster, which says, okay, I need to execute this workflow using Slurm. And you can see, for example, how do you actually configure that? So it's like process.queue, and then you say, okay, production within my HPC cluster, which runs Slurm, I need to use a production queue. And finally, you can see a Google batch executor configured there. I'm gonna go over this in slightly more detail when we run the real example that I have. So I was saying basically, and this is how you execute that. You point it, you run Nextflow, you point into your workflow, and then you say, okay, run this on a profile using the profile local to run it on your laptop, profile cluster, if you want to run in that particular Slurm cluster, on or cloud if you want to use the Google Batch executor there. So this webinar is about how we can actually run Nextflow pipelines in the cloud. So why do we even care about that? Cloud has a few benefits. For those that are not aware of it, you can basically, the promise is that you can scale on demand. So as long as you can pay for it, you can scale up without having to worry about buying hardware, which is really good. It also gives you the opportunity to access hardware that may be too expensive for you, or that because you only want to run there like once, it doesn't really make the case to actually buy that. For example, using GPUs or any particular, another use case, like very big high memory virtual machines. That is another one that they're quite expensive to buy. So if you only want to run it once, maybe the cloud is an attractive way of doing that. Because you only pay what you use, basically, that's it. You only, as long as you are using those resources, you are paying for them. If you're not using them, that's it. There's no cost you need to pay for. It does require less maintenance. This is debatable, I would say. You do need to maintain the virtual infrastructure within cloud providers. But Nextflow makes it quite easy, so there's not that much infrastructure you need to manage. Definitely, you don't need to manage any servers, which is really good. And then another thing that is really useful, at least from my experience, that the storage is not really a limiting factor here. As long as you can pay for it, things like AWS S3 or Google Cloud Storage grows unlimitedly. That is not really true. It's not infinite, but it's quite big in terms of probably what you need. So I just want to touch point on how actually Nextflow connects to Google Cloud. Hopefully you can see my cursor here, but on the left-hand side, you can see Nextflow head job. So basically, that's how you run the process. Nextflow is going to connect directly to Google Cloud through the APIs. And it's going to call what is called Google Cloud Batch, which is the batch execution engine within Google Cloud. This one is going to take care of like scheduling jobs and making sure that everything runs as it should, that the sizes of the resources they're using are the ones that you need based on the workload itself. What batch does behind the scenes basically orchestrates and run the jobs in virtual machines and in Compute Engine, which is the Google Cloud Virtual Machine Service. So it does everything automatic for you. So whenever that job needs to be run, it basically fetches an instance on Google on Compute Engine that matches the requirements. I will like spin it up. It will do all the setup and then will run your process there. The third component is the cloud storage. That's basically where you need to keep your inputs and outputs of your pipeline. That's what it does to keep track of everything that's going on. The third component of all of these communications is basically the Nextflow, the head job, is going to communicate to Google Cloud Storage to keep track of like the working directory and whatnot. So this is roughly how it works in a relatively simplified way. Okay, at this point, we hopefully know what we need to use for workload management system, and why Nextflow within that, what are the benefits of using that. Also, how Nextflow can actually run, why would we even consider running things on the cloud, and how Nextflow runs, communicates with Google Cloud. So now we need a real pipeline to do this. This pipeline is part of the Finding Fino project. I encourage everyone to go and check it out. You have the link at the bottom there. This pipeline is basically allows you to get a taxonomical and functional profile from low shield metagenomics sequencing project. Basically, by having a relatively low cost sequencing project, you can sort of like infer the potential functional taxonomical overview of your sample. Alejandra did most of this work, so she is the expert on this one. You can follow this pipeline is published on as a preprint on the archive, so you can go and check it out, and you have a link to the GitHub link there. So let me quickly move to my terminal. I would ask Familia to let me know if there are any questions of like if the size of the terminal is big enough. Slightly bigger.
I can see well.
Okay, perfect. So
thank you.
For this very short demo, I'm going to run the biosifter pipeline in Google Cloud and see how you can actually achieve that. So as I was saying, one key component of running these Nextflow pipelines in different infrastructures is to have a configuration file. So I have one here. I'm going to open it. So again, this sort of roughly looks like the one that I showed over there, but it has some more details. I'm going to skim over some of the less important bits, like pipeline parameters, for example. I'm going to go directly to the Google Cloud configuration. First of all, I need to configure the executor. So I'm saying, okay, I'm going to execute this pipeline on Google Batch. So that gives Nextflow the instruction to do that. This is another sort of like pro tip. So because whenever we run a process anywhere, basically they may fail, and there are like many different reasons for that to happen. So a process may run out of memory. It may just that one VM is restarted somewhere. So we need to define a error strategy. So we are instructing here Nextflow to say, when a task fails with this particular exit code, which I'm going to explain in a bit, retry that process. Otherwise, just terminate the whole pipeline. I'm going to try that at most 5 times. So there you go. This is how you sort out something here in Nextflow. It does it automatically for you. I'm specifying like a blanket disk of 50 gigs for this pipeline. And then I'm going to jump quickly to the particular of the how we configure Google, the executor directly. So whenever I'm running things on Google Cloud, I need to specify the project. Don't pay too much attention to that. That's probably dependent on whoever created the project for you. I'm going to say I want everything to run on Europe West 2, which is London. We are based in Cambridge, so it just make it easier for me. And then I'm specifying a few things within batch. This is authentication level stuff, so I need to specify a service account, email in this case. If I need to authenticate, I want to make sure that Nextflow can use the API, so it's going to use this user to communicate with that. And this is important, this spot too. So most cloud providers have a bunch of capacity that is being underutilized in their infrastructures. For example, VMs that no one is using, which are like just not being like shares of compute not being used. So they do offer that that capacity at a lower cost. So you can ask for a VM, which are called like spot instances. So you basically, they will charge you less for those VMs that are like running on infrastructure that they basically just have laying around. But the caveat of that is that they may reclaim that VM or those resources basically with a few minutes of anticipation. So you may be running a pipeline, like a process in one of those spot instances, and then you may just like get killed by Google because they need to use it for someone that's going to pay like the premium price for it. But this is a really nice way of saving money when you're using Google Cloud, or AWS has the same concept. I'm not sure if Azure has the same, probably has, because they are like much cheaper. Like it depends on the flavor of VM that you're using, maybe up to 10 times cheaper. And that's why, coming back to the error strategy here, this exit code means that. So Google Batch is going to fail the process with this particular exit code whenever the spot machine was reclaimed. So that's why we're like retrying. There's no way to escape from that. So basically the machine is going to get killed, so you may just run it again. So that's the configuration file. Let's go to the actual process I used, the actual command I used to run it. So I have Nextflow installed in this environment. So I'm going to use it to run the EBI metagenomics biosifter. This is the GitHub URL. So if you add github.com/EBI metagenomics biosifter, you're going to end up in the repo. So you can see here that it's basically, it's going to automatically pull the pipeline directly from GitHub. This is a revision. This is going to use version 1.2.1, which is a release on GitHub. So everything is being handled for us. I find this very convenient. Then I'm going to specify in a configuration file and the profile for Google Batch. I'm going to skim over these ones. Don't worry too much about them. And then I'm specifying, okay, this is the input file, which is like a CSV with all the different samples I need to process, and this like pipeline-specific parameters. You need to specify the work directory and where you want to store the results. And see properly. So now I'm going to just run that and see what happens. Hopefully it will work. Because I want to go over a few things in here. So, okay, it's booting, Nextflow is coming alive. It's telling, okay, I'm launching that pipeline. Oh, sorry, I forgot to do something. Post slide demos. So on the first line there that says launching, it gives you the link to the pipeline itself in GitHub. Every single instance of our pipeline Nextflow gives a name over again. Then you can see actually the commit is actually checking out. This is very good for provenance, so you know, except specifically which commit you're running. Then it prints a bunch of different parameters of how you were running it. Don't pay too much attention to it. And this is basically how it runs. Just want to highlight one more thing here, because I ran this previously. It's caching that. So let me quickly go. Hopefully you can see my browser. I just wanted to go here. This is Google Cloud, the dashboard. So I'm just trying to see if I can see the jobs appearing. Hopefully it will appear. There you go. So let's go back. This is batch. Within Google, the dashboard, you can see access all the different services. So I have the batch, which is the service that is used to schedule the jobs. And this is running a job here, and you can see the name, and this is where it's being stored, and so like the number of CPUs and whatnot. So Nextflow is feeding that directly to Google Cloud. Batch, the batch service is spinning up a VM, a virtual machine within the compute engine, which is going to run my job, which is already doing. So I think it's booting up at the moment. And that's basically how you run the process. Let's go back to the terminal. This may take a bit of time just because it's running. Okay, we can come back to this one. So let's just assume this actually finished. I'm going to go over the execution report. So this is what Nextflow gives you at the end when you finish the execution of your pipeline, which is massively useful. You can see what actually Nextflow command you run. You can see all sort of like information which proper and whatnot. And I think one thing that is really useful, especially when you run things in the cloud, is you want to take a look at the resource usage there. And I'm going to touch base on a little bit on that in a bit. So you can see this, you get this by default. You have to use a particular flag within Nextflow. You can find it on the training. So you can see basically you get how many, in terms of how many CPUs we're trying to use and how many you actually end up using. The same with the memory, how long a job actually took, and the number of like IO, which is basically disk. Hopefully this has finished now. No, it's still showing. Okay, this will eventually finish. So I'm gonna go back to my presentation. So that was a very brief demo of how you can actually run a Nextflow pipeline in Google Cloud. One thing that I didn't talk about is what are the cons of running things on the cloud. I think this is based on my experience. It's not meant to be an extensive list of like things to consider. These mostly things that I bump into. I think the most important one and the one that most people flag is basically the cost. So even though you pay only what you use for, it is very easy to make a mistake and ended up having a massive bill. Just I think the most common issues are basically when you transfer data in and out of Google's of Google Network. Basically, when you say, okay, I run a bunch of pipelines in there, I want to pull the results back. If you have large amounts of data, I'm talking about terabytes and terabytes, that's going to become expensive at some point. Another thing that just happens every now and then, if you don't clean up your, as you go, basically, if you process a bunch of data, you need to clear up your storage. And that I mean, just don't leave stuff laying around in cloud storage, because that's going to build up over time. And it's quite easy to miss because it's not something very visible. And then overshooting your requirements, asking for way too much. For example, asking for big, like asking for, I don't know, large amounts of data on a process. For example, asking for, I don't know, 100 gigs of RAM for a process that only needs to run with 1 gigabyte. Basically, that's over provisioning. It's gonna force batch to create an instance using a really expensive machine, because big memory machines tend to be quite expensive. So you are basically paying for compute that you're not using. You're asking for 100 gigs and only using 1 or 2 or whatever. So you need to take care, and that's coming back to the Nextflow report. Always try to adjust that. And again, even though it's quite simple to set up the whole process, I didn't go into the process of like setting up the project and whatever you need to do to actually get it set up. It's very simple and trivial. I linked that at the end. And again, when things don't work as expected, you have another layer to consider. So whenever batch doesn't like what you're doing, so you have another thing that you need to take care of, debugging that. Sometimes it's easy, sometimes it's not, for example. So there is a bit of extra complexity to take into account, and you need someone to actually know how to set up things on the cloud. These are links which I find useful if you're interested in running any of these on the cloud. Like I'm linking to Nextflow itself, Nextflow training, how to do the setup on Google Cloud and also on AWS for those that prefer that provider. And I think with that, I'm happy to finish. Thanks, everyone.
Thank you so much, Martin.
I spoke slightly slower this time.
Oh, it was perfect. A lot of people gave us feedback on the audio and said it was working fine after. So I'd like to thank you for the presentation and also thank all the audience for the feedback and as well for all the questions. So we have quite a few questions, and there is even someone who already kind of started to reply to some of the questions. So I'll start with the most upvoted one, which is someone is asking if it's better SnakeMake or Nextflow. So if you have an advice on it.
That is, I mean, yeah, I am very biased to Nextflow because so EMBL-EBI, one thing to consider. So I am myself an advocate for Nextflow itself. So I am part of the Nextflow Ambassadors program. That doesn't mean they're paying me or anything. It's just part of a community trying to make the adoption of Nextflow grow, basically. So I am very biased for that. So I'm probably not the best person to ask on that one. And I don't have that much experience with SnakeMake. So yeah, I think Nextflow has a bigger community There's a project which I link in the YouTube link called NF-Core. So those are a group of people that work with Nextflow that has built loads of different pipelines for different domains. Most of them are for omics, but they're really high quality pipelines ready to use. So I think, from my perspective, the community in Nextflow is bigger. So I'm not going to talk about the details about the language itself. I just feel that the Nextflow community is bigger. So that's maybe useful for you or maybe not. Hopefully that answers your question.
Thank you. I would connect to this and take a few more questions about Nextflow, because someone is asking if it's an open access program. Someone else is asking if you have some links to some resources, which I think could be what you link at the end of your slides. And
yes,
just a reminder, we will provide the slides tomorrow for everybody who attended the talk.
Yeah. Nextflow itself is open source. You can see it on GitHub, and I don't remember the license, but it's free to use and it has an open license. I think it's like MIT license, so it is open and free to use, so anyone can use it.
Okay, thank you. And I see someone provided the link to download it already in the Q&A. Someone was asking, how can we try it? So I guess that question is already taken. Someone is asking, how can we work with Nextflow and R or Python?
Yes. Yes. So let me go. Sorry, I'm not sharing my screen. Give me 1 second. So I'm gonna quickly go to my slide because I think it's useful to have an example. Can you see my slide now?
Yes.
No, sorry, just this webinar remote thingy. I'm not so used to it. So in this example here, within the script tag, basically you can use any languages that you want. I think it supports Python, R, and a few more. So I think there is a connection between the environment you are running the process in, which is, in our case is provided by the container. You can also have a conda environment. So wherever you have the Nextflow is going to activate the conda environment, or it's going to run things within that container. So provided that you install what you need in the container or the conda environment, you can use any languages that you want. So it's quite agnostic from the language itself. Hopefully that answers the question.
Yeah, thank you. Someone else was asking a link to this. When you were showing at the beginning, I think there was those slides. Is there a specific language used to run this process? So I think it maybe was like if Nextflow has specific commands maybe that are typical to the program itself, or if you just...
I don't think so. I think so. I will, yeah. Hope maybe I'm getting that wrong, but I think, yeah, coming back to you can use any language provided you can provide the environment for that to be executed within Nextflow. So you don't run processes within a workflow on your own. Basically, how things are run is defined by how data flows through the workflow. So basically, in the example, this is a mini workflow. So this is like 3-step workflow. You're defining, okay, this is the input file for your pipeline. You can think of as that, so like a FASTA file you have on disk. That's being fed to the inter-scan result. That's going to be executed, the process. That's going to be executed first. And then after that's done, Nextflow is going to send the output file from that process to Santis, which is the second one. So how things are executed, it's up to Nextflow. Nextflow does it for you, basically. So you need to only define the dependencies between that.
Okay, thank you. So I've just one other question that could be linked to what you just said. Someone was asking, can we run files stored in our PC? So locally, basically.
Yes, you can run things locally. Absolutely. Yeah.
Thank you. So moving on to the pipeline. So someone is asking, is it possible to configure the pipeline in such a way that some parts are run locally, and then when we want it, we move it to the HPC?
Yes, that is a good question, and I think that's a very useful pattern. For example, if you don't have access to expensive GPUs, for example, but you want to spend money running like things that you can locally, you can have a hybrid way of running your pipelines. And I don't have it here, but I didn't cover that. But you can specify. You can say, okay, within your config file, you can specify inter-scan. I'm going to run that on Google Cloud, and I'm going to run Santis locally. And provided you configure things properly, Nextflow will basically do that for you. It's gonna run your workflow locally, for example, if you say so, and then it's gonna spawn up. It's gonna connect to Google Cloud for your interproscan process, and it's gonna copy the files I need over to the cloud. When that's done, it's gonna copy the results back to your local environment. That's gonna run the second process. So it is possible, and you can find it in some of the links that I have, like hybrid execution is possible. Yeah.
Thank you. Someone was asking, can we use this as parallel processing, which I guess means if you can run in parallel.
That is a really good question. And I think probably I didn't cover that. Yes. So Nextflow will know how to execute things. For example, if you had, in this case, if you had another process here that has a dependency with interproscan, I don't know, imagine you have Santis 2, for example. Nextflow is going to know, okay, are the dependencies for Santis and Santis 2 fulfilled, which is going to say yes, because the interproscan result is done. So it's going to run, provided that you have enough resources, it's going to run those two processes in parallel. So basically, as soon as things can actually be executed, Nextflow will run those in parallel. That's one way of thinking about parallelization. Also, for example, in this first line here, if you say, I have many files, you can actually make it so that this protein is actually a list of files. So Nextflow is going to iterate over those. It's going to launch as many interproscan inputs as you have in your input, basically in the protein file. So that's another way of parallelizing. So yeah, it works very well for that.
Thank you. Then someone was asking, can we import file from Nextflow to multiple devices? So I guess there would be more an output if it's...
Yes, you can. Yeah, the outputs are basically files, and you can, Nextflow has a section in documentation on how to publish outputs from your workflows. And you can publish those locally, and you can publish those into a bucket, depends on where you're running things. But at the end of the day, it just, I don't know if this answers the question. Okay, you finished. So I'm gonna have the results here. For example, these are, I'm gonna make it bigger. These are actually the results of that pipeline. And there's just like files on my file system. So you can move them around as you please.
Sorry, I was going through another
that's
question.
perfect. That's fine.
And I got lost a moment. Someone was asking, when you showed, I guess, a specific case study, how many samples are included in each batch in this case? When you were showing your...
Yes, in my example, yes. I think only one. I'm trying to find something. I think only one. Yes, only one. You can see it here. Because I wanted to make sure that it runs very quickly. But yeah, you can have as many as you want, basically. Yes, and this was like keep running things as soon as it can run things, it will do so. You should be, if you are running on the cloud, be careful with that, because you may end up spawning many jobs. So yes.
Thank you. I would take a question that is maybe kind of connected to this, because you said be careful when you do it on the cloud. Someone is asking, is there a guide for knowing how much RAM we would need? And can we test this locally? Or
I think that is a very on a tool basis. I don't think there's a recipe for that. So I'm going to try to demonstrate things if I can. So for example, I'm going to go, this is the report that you get at the end of the execution with Nextflow. And you can see here how much memory one process actually uses. It's like 15 gigs. So it depends. Yeah, I won't be able to find the code quickly, but if, for example, there you go. You have the percentage of allocated memory. For example, you can see here, I am running a bunch of processes which are like, this is how much memory I asked for and how much memory I actually ended up using. So if you have things really low here, we basically are overshooting. So I'm asking for, I don't know, 10 gigs of RAM and then using 2 gigs of RAM. Again, depending on how many of these things you need to run, that could be a problem or not. I think that's one of the things that happens when you're running things on your own HPC cluster. In my experience, in some of the clusters that I've worked in, there's not a big penalty for over requesting things. You may end up being, your jobs may end up being having like a penalty on the fair share, so it may end up take longer for those to be actually executed. But that's as it works as it gets. But when you're running on the cloud, if you're asking for a big machine, then you're paying for that, even if you're not using the whole thing. So there's a bit of like an exercise for like trying to adjust your processes based on what you actually need. But there's no recipe for that. I think the tools you're running on, the inputs also may change how you behave. So there's a bit of like a manual process that you can use the report to try and guide that. But there's no like rule of thumb, basically. You need to run it and see what happens.
Thank you. Sorry, as question keeps on coming, my screen goes up. Someone said, I'm building a tool, but I'm stuck with workflow. So I don't know if they want to, maybe if they're asking some advice, they want maybe to specify something and we can take the question later. Someone else is asking, do we know of any European cloud provider where this would work on?
I'm not sure. I don't think, I know, the whole, sovereignty of data. I think Nextflow has connected with the main public cloud providers, which are basically Google, Amazon, and Microsoft with Azure. I don't think there's anything that works like that, as far as I know. The closest thing that you can get is probably, running, I don't know. Sorry, I don't know enough about the European sort of like cloud providers enough. But I don't think Nextflow supports any of those probably minor players. It supports the bigger ones, which are American, but you can also have, for example, I was running, it depends what you worry about. So I was running all of my compute in the cloud. I run it on the London data center, either on AWS or Google Cloud. For us, it's easier, but you may have like regulatory implications that you may not be able to run things in different zones. That's a whole area. So sorry, I will check documentation.
Thank you. Someone said very nice presentation, so we'll still take the comment.
Thank you.
Someone else is asking if you can share resources on how to implement Nextflow pipeline, Nextflow profile locally and on institutional HPC. I don't know if some of the links you provided could already kind of cover this question.
It is there, but basically to get these nice reports, there's a flag that I think is called --with report. This is built automatically for you. So check the documentation. That's an example about traces and reports there, and you can see which flag to use. And this works not just in cloud. This also works locally. Like if you're running in a Slurm cluster, for example, or any other kind of like HPC scheduler, you will get the same information.
Thank you. Someone is saying, I assume calling directly from GitHub is very straightforward. Is there a simple way to they wrote C, but maybe they meant to do it? I don't know if this question makes sense.
Sorry, I was.
Don't worry.
Yes. So no, that's fine. I can think I can try and show that. So I have my run example here. This is basically the line that it does it for you. So Nextflow run. This is EBI. This is our repo. I'm gonna go over that so I can actually show you that I'm not. So if you go GitHub EBI, this is open source. This is free to use, and this is the link basically. So what Nextflow is doing is adding basically is connecting to GitHub, finding this repo here and pulling this particular release, which is here. So that's like automatically integrated. So I don't have to do anything. It's just like it will know where to put things. If you have things in like Bitbucket or any other like Git-like repository, you can specify that in a configuration file, if that's something that we like to. Hopefully that answers the question.
Thank you. Okay, there are some questions about certificates recordings. I will just take this at the end, so focus a moment on the scientific ones. So someone is asking, are there containers installed in the cloud that can be reused?
Yes, there is. There are a few resources. So I'm going to go to different things. You have biocontainers. Let me see if I can find it. So there's in bioinformatics there is you have bioconda and you have biocontainers. Bioconda is for conda environments. Also, the same people basically build biocontainers. So they are wrapping those conda environments in containers which are freely available. So you can use them. This is going to take some time, but it's called biocontainers. So yeah, we use many of these basically. We have even contributed a few of them. So yeah, there is a public repo of freely to use containers. This is only covered by informatics, but I think is related.
Thank you. Then we have a question that I believe is referred to the pipeline that you showed us, a case study, because you say this pipeline comes with automation. You mentioned they can run half locally and half in the cloud. So I guess they want to know if this can be automatized. So maybe similar to the question that we had before, like if you have like half and half, can it just be automatic? You don't need to do anything. The pipeline runs.
I don't think there is. There is a service. So Nextflow is built or developed by a company called Sikira Labs, which I didn't went into that in this presentation. And they have built which is linked on the my useful links. They built a platform called Sikira platform that allows you to automate a bunch of this stuff. Basically, you hire them, basically you like use the service, and that service you specify which pipeline to run, and they will like put up the infrastructure for you. But I never used that one, so I'm just linking that in the slide if that's useful to anyone else. But there's always a bit of like manual setup that you need to do at some point. But Sikira Compute make it easier, as far as I know.
Thank you. Okay, next question is, in HPC jobs, multiple files can be sent in an array job where each file enters a thread at a time. But sometimes you have multiple processes in a pipeline in which one could be in an array job, but other cannot. How can you manage this kind of bottlenecks with Nextflow?
You have, so I think 6 or probably a year ago, Nextflow added support for job arrays. Job arrays are a way of like, so what happens? If you have a very complex pipeline with many different processes, an issue that the schedulers may have is Nextflow is gonna, as soon as it will just like, it will try to schedule too many jobs, making the scheduler struggle to keep up. So job arrays basically are a way of like bulk scheduling a bunch of jobs which are very similar to each other. So that's way of like control. So basically you don't flood the scheduler with too many jobs. So there are a few mechanisms to do that. So you can specify how big the queue, if I remember correctly, you can specify how many jobs you can want to run in that job array. And there's a way of specifying that at the process level, as far as I know. But you can also specify how many jobs in total you can run. For example, you can say, Nextflow, you're running in Slum, be gentle, don't book more than 300 jobs at a time. So that's why I'm like limiting that. And you can also, per process, you can specify how many jobs of that type you want to run. That directive is called one of those things that you specify in the process. You can say max for 10, and it will only run 10 of those at a time. There are no, so with those two, you may, depending on the nature of the workflow, you may end up being able to adjust that. But from the look of how that question is answered, it probably is a complex workflow. So you will need to tweak a few knobs to make it work for you. And those are basically the things that you will do. I will check it out. The Nextflow documentation has a bunch of that. Yeah.
Thank you. So we still have a couple of questions, so I guess we can take those and then conclude the webinar. Someone is asking, let's say I want to build an application which can be then used by other user. So I want the user to give an input and select the parameter, and then they get the output. So for these pipelines, if I use Nextflow, which I developed locally, like on my computer, what steps should I take so that then it can be used by anyone from their PC?
Okay. So yeah, that's an easy one. I can hopefully explain the steps. So I think the easiest way of doing that is you develop your tool locally. You build a Nextflow pipeline for your tool, and you basically then make it available in GitHub, for example. That's sort of like the default way of sharing software. If you do that, then people can just use the built-in Nextflow integration with GitHub, and just like point it to the repo within the Nextflow run execution, and it will pull it up that automatically. I feel that's the easiest way of sharing a Nextflow pipeline with the community. Just like put it somewhere that is accessible, and then let Nextflow handle that for you. Hopefully that answers the question.
Thank you. Okay, someone is asking, is it possible to incorporate an interactive session, such as launching Napari to visualize images at a certain point when we run the pipeline? So the pipeline pauses for the user input and then continues based on that.
I don't think so. That's a good question. That will use it in some cases. I don't think you can. It was just like it will run the whole thing for you. I don't think you can have that kind of like interrupt. As far as I know, you can do that.
Thanks. So final scientific question. Someone is asking if Nextflow is mainly focused on bioinformatics or if it's also used on other domains. Just general wrapping up.
It was Nextflow itself comes from an institute in Barcelona, which is called, I don't remember how it's called, but it's come from a bioinformatics institute in Barcelona. So it has a bunch of, so the biggest community is bioinformatics itself. But it's not constrained to that domain. You can, I actually ported a pipeline, a machine learning pipeline from a collaborator into Nextflow, and it works just fine. So it's not constrained. You will see that it has a bit of like bias to bioinformatics just because the community in bioinformatics is quite big. So within NF Core, there was recently a pipeline published there which was used for image analysis. I don't remember the domain, but it was not bioinformatics. So there's a slowly growing community of non-biology users of Nextflow. So yes, I would encourage you to connect with them.